Hello! Today you'll be learning about how to build a robot in Vex. So, when you build a robot in Vex Robotics, you have three basic frames. These are three frames that are good for beginners, starting with the box frame. This is the first frame that I ever built. It consists of 4 metal pieces put together, connecting each corner, and it leaves a good amount of room for electronics in the middle. It is a very bulky design, but it is very adaptable. You can make it longer or shorter depending on your needs. With the arms, with the two sides, you can put more than 2 motors for each part. So, for example, if you wanted to increase the gear ratio of, say, the back motors, by putting, say, your motors here and here, the wheel right here, you have a lot of space in all three of these, which is why they're good. To increase the gear ratio by putting smaller gear here, a larger gear here, or, for example, a smaller gear here and a larger gear here. Also, with the box frame, something that you really can't do with the H frame is you could run your drive system with only 2 motors instead of 4. Instead of having motors 1, 2, 3, 4, you can have motors here and here, and have a gear system which allows for wheels to be here and here. So instead of which would frees up motors and makes driving just a bit easier. So this will replace this. Then the benefits of an H frame. H frames are more streamlined. Cons of an H frame: it is easier to not for your 2 parts to not be equal. So say that this side is to more of an angle than this side, you will get drift when you are driving forward or making turns. One quick way to remedy that is when you fasten these 2 plates of metal to this plate of metal, make sure you have more than one connection. You can see that, so when you connect this middle plate to these 2 plates, make sure you have more than one point of connection. That'll ensure that there's less wobble between the 2 plates and the middle plate. And then finally, we have the U-frame. The U-frame frees up your front more. So say you had a grabber on the front where you needed to, say, with your drive system back here, a wheel here, and this has the same benefit as the box frame, in which you could drive these motors with 1 motor here and a system of gears. And then this frees up the front for, say, an arm, or if you needed to grab an object and you needed to have 2 like little conveyor belt type things to pull something in. You free up the front of your robot a lot with that, and gives good space to electronics in the back. Very good for front sensors, just as good as a box frame. All the basic frames have their pros and their cons. For beginners, I suggest you start with the basic box frame, easiest to build and easiest to maintain. If you want to go a little bit more advanced, go to the H frame, get a little bit more complex of build, and you can do more complex robotics. And then the U frame, which is the most complex of the 3, it requires a little bit more engineering to get everything centered. But they all have the pros and cons. All right, so once you have your frame, we move down to our wheels. So there are 4 basic types of wheels. for your beginner level wheels, you have your small and your medium wheels. Small wheels, almost like skateboard wheels. Your medium wheels, these have a little bit more grip to them. Pros and cons of using smaller or larger wheels. Smaller wheels, or larger wheels will give you more traction. That's pretty much it. Smaller wheels are good for smaller robots. It wouldn't really make sense to put small wheels on a larger robot, but you could put larger wheels on a smaller robot depending on what you're trying to do. Then there's two more advanced types of wheels, the omnidirectional wheels and the holonomic wheels. So omnidirectional wheels, they allow for a robot to move straight by rotating the wheel forward, and to move left and right. Say, for example, if you can move the camera, please. If you can zoom in on the wheels. This robot has been outfitted with 5 omnidirectional wheels. So that means that it can move left and right without any resistance on the wheels, and it can move forward and back with this also an omnidirectional wheel in the middle that allows for it to go, instead of just forward, back, left, and right, it can go 360, so it can move that way and this way without being hindered by too much traction. Now, if you wanted to do that with less wheels, you could use the holonomic wheels. Holonomic wheels, they use counter rotation to move forward and back, but their natural position when pushed forward is to go at a 45-degree angle. So when they rotate forward, if you have more than one, if this one was to rotate forward and this one was to rotate back, it would actually turn. It would actually go forward. And with that, you are enabled with just 4 wheels, you can go forward, backwards, and at a diagonal. It's only 4 wheels. With any other system, with just the smaller to medium wheels, basic wheels, you would have to just rotate using all 4 wheels. With omnidirectional wheels, you have to use the 5th wheel to provide lateral movement, and so the holonomic is unique for that. The con with using omnidirectional and holonomic wheels is that they do not give as much traction because they are made to be able to move in 360 degrees. So that means that if you are in competition or you are doing a certain thing where your robot will be pushed or face any type of resistance, it will not hold up as well as the smaller medium wheels, which give traction because they do not have lateral left to right movement. After you decide on what wheels you want, sensors. So there's 6 sensors. We only have 4 of those, but there's 6 of them. There's the button sensor. Basic button. You click it, the robot does something. That could be useful for, say, if in a less practical sense, if you're playing freeze tag with your robots and you had 2 robots, and if one gets bumped on the sensor, it freezes, it stops for a certain amount of time, say like 5 seconds, and then a more practical use, say if you wanted your robot to navigate a certain area, so you want to go forward, left, and then stop. You can press the button and have it run that code. Then, motor encoders. This is the motor encoder. So motor encoders are very useful for autonomous programming and autonomous robotics. They count the rotations of the axle when connected to a wheel, which enables you to sync the 2. If you have 2 motor encoders on 2 wheels, you can have your robot recognize how many rotations each wheel is doing. So you could track it and say, if you want to navigate a room, you could tell your robot, I want both sets of wheels to rotate forward 50 times, and it will go forward that same 50 times every time. It's very, very useful for navigating and with the use of other sensors for autonomous robotics. And then we have the ultrasonic sensor. So ultrasonic sensor uses sound waves to track distance. So with that, you could see, the robot will be able to basically have its own eyes and see how far or close it is to something. And with that, you can set the robot to do a certain thing when at a certain distance. Next is the line follower or the color sensor. The line follower or color sensor allows for the robot to see a certain color and to perform a certain action. So, for example, if you had a black line on a white floor, you can have the robot follow that black line, or if your robot was moving forward, you could have it stop at a black line and do a certain action, such as turn around or go left. Then, we have the limit switch. The limit switch is basically a resistance switch. So, similar to a button, it will track how much pressure is being pushed on this little switch right here and do a certain action. Finally, we have a potentiometer. So potentiometer tracks the rotation and position of a motor axle. So that would be useful for, if we come over here, if you had a potentiometer on, say, a robot arm, you could track to what degree the robot arm is up or down. And that's our final sensor. All right.